Dear friends, today we are going to discuss engine nomenclatures or its terminology. In the last lecture, we already started to discuss about the engine. So, very important definition of the engine which we had in the last lecture itself. That is nothing but engine is a device which is used to convert the chemical energy which present in the fuel into the heat energy. And that heat energy is again utilizing for doing some mechanical work. Such kind of a device is nothing but called as an engine. Now, when we are going to talk in detail about the engine, then very important thing which we have to learn, that is nothing but called as the engine nomenclatures or its terminology. So, dear friends, in the last lecture only, we had the different constructional details of the engine along with its components. We discussed what do you mean by valve mechanism, piston, cylinder head, crankshaft, crank pin, etc. etc. These are the different components of the engine. Okay, so on your screen here we have one cut section model of a single cylinder engine. Now with the help of these diagrams, we are going to learn the very important nomenclature or the terminology of the engine itself. Unless and until understanding of all these nomenclatures, we will never get the thorough knowledge of the engine. Okay, so this is very important kind of a lecture. So again, here we have one cut section model of engine. This is a piston, as we know. Now this piston is always reciprocate inside this cylinder, and this piston connect along with this crankshaft with the help of one device, and this is nothing but called as a connecting rod. The small end of this connecting rod is connected to the piston and big end is connected to the crankshaft. And as I told you earlier, let us consider this crankshaft is directly connected to the foot lever. If you can take the example of your two-wheeler, the foot lever or the kick of vehicle is connected to the crankshaft. Means when we are going to apply some pressure force or foot force on that particular foot lever or that kick itself, then the crankshaft or crank mechanism will start to rotate, and because of the connecting rod, piston will start to reciprocate inside the engine cylinder. Okay, later on we will discuss about the working and other things. Okay, now here we are going to discuss about the engine terminology or its nomenclature. Again, the valve mechanism, inlet valve is there, exhaust valve is there, spark plug is there. Okay, so these are the basic components. Now here, if you concentrate, the different things are present: top, dead, center. Then this one is a stroke. Then this is the bottom, dead center. Now this is about the reciprocating motion of the piston, cylinder wall, clearance volume, and this is the bore. Now what about this? Okay, so dear friends, this TDC, BDC, cylinder bore, stroke, clearance volume, swept or displacement volume, compression ratio, cubic capacity, these all terms combined together is nothing but called as engine nomenclature or its terminology. Okay, getting. So here we are going to understand one by one the detail about this engine nomenclatures. Okay. This thing is very important. This concept is very important to understand. So the things about the engines are totally depend on this terminology. Okay. So here I am just giving you quick review about this particular nomenclature with the help of this diagram. Okay, so always remember, dear friends, bore means what? Bore is nothing but the inner diameter of the engine cylinder is called the bore or engine bore, or sometimes we can say the bore diameter. Okay, what I said, the diameter of the cylinder is nothing but called as the bore, means we can say inside which the piston will reciprocate. The diameter of the engine cylinder is nothing but called as a bore or simply bore diameter. Okay, always piston reciprocate in between the two dead centers. Okay, now we move to see the another diagram. Now please concentrate on this left diagram. So whenever I'm going to talk about this particular diagrams, please concentrate on the mouse indicator. Okay, so again here we have the two-dimensional diagram of the same. Again, piston is there, cylinder is there, piston reciprocates inside the cylinder, and these are the two walls. One is the inlet wall, another one is a exhaust wall. Now here there is one line which indicates TDC, and there is one line which indicates the BDC. And what do you mean by this TDC and BDC? The meaning of TDC is a top dead center means what? Whenever piston is moving from bottom side to top side, it will not move beyond this particular limit or beyond this particular point, and this topmost position of the piston is nothing but called as a TDC. Okay, if you see in the diagram, here is that particular TDC. Okay, means whenever the piston will start to reciprocate, it will reach up to this topmost point. Beyond that, there will be no any kind of a possibility of the movement of the piston. See, this topmost position of the piston is called as the TDC, and similarly, whenever piston is traveling from this top to bottom, it will reach up to this maximum lower limit, that is BDC. It will never move down beyond this BDC limit. So bottom dead center, the full form of BDC is what? Bottom dead center. So simply TDC is nothing but top dead center position of the piston. Beyond that, piston will never moves up, and similarly BDC is bottom dead center. Beyond that, piston never moves down. It always travel in between TDC to BDC. Always remember. And whenever piston traveling in between TDC to BDC, it travels some distance. It travels some distance, or we can say the length in between the piston traveling from TDC to BDC or BDC to TDC, that is called stroke or simply stroke length. Means simply if piston is moving from BDC to TDC only for one time, then we can say there is one single stroke. Again, if the piston is moving from TDC to BDC, the another stroke is there. Again, if the piston is moving from BDC to TDC, the third stroke is there. And again, if the piston is moving from TDC to BDC, that will become the fourth stroke of the piston. So this describes the stroke itself. And the stroke, we can measure the stroke in the form of length, that is the stroke length itself. Okay, so we just had what do you mean by TDC, what do you mean by BDC, then we discussed about cylinder bore, and we just discussed about the stroke. Then now we are going to talk about the clearance volume. Now where is the clearance volume? Now here is that clearance volume or the clearance space. Okay, now we shifted to see in this another diagram. So we just had the topmost position of the piston, that is called the TDC, and it will never move beyond this one. So there will some kind of a gap in between this particular cylinder head and the piston top surface. There should be always some kind of a gap is present over there, and this gap is nothing but called as the clearance volume. This piston never strikes the cylinder head or this particular valve mechanism. There should be always some gap. Okay, there is always gap in between the topmost position of the piston and the cylinder head. Cylinder head means what? This top portion of the cylinder, this top portion of the cylinder is called as the cylinder head. There is always some kind of a gap, and this gap is nothing but called as a clearance gap or clearance volume. Okay, now the next one we are going to talk about the swept or displacement volume. So as we just discussed, what is the meaning of the stroke? Stroke is nothing but the piston is coming from BDC to TDC or TDC to BDC always, and that is called a stroke. Similarly, when we are going to measure this particular thing, when the piston is traveling from one dead center to another dead center, it displaced by some volume. Okay, So whatever volume is displaced by the piston when it is moving from one dead center to another dead center, this is called swept volume or displacement volume. Okay, in simple, water volume swept by the piston when it is moving from or traveling from TDC to BDC or BDC to TDC, that volume is nothing but called as a swept or displacement volume. Okay, so the next one, this is the compression ratio. Okay, now to understand the things, now we are going to move to see handwritten notes, and it will beneficial to all of you to understood this particular concept in well manner. Okay, so here we are going to direct it to the notes itself, and that will gives us good understanding. So this is something about the jet engines which we discussed. So this kind of a notes will provide you later on. So as we already discussed about engine components and nomenclature in that PPT itself, now such kind of a diagram, whenever the question will come to you in your examination, you have to draw this diagram. The question will come like give a complete explanation about engine components. That time you have to draw this diagram and you have to show these components of the engine. Okay, and you have to describe in your own words. So now our today's point, that is nomenclature of the engine. So as I just discussed, the bore diameter, see this is a simple diagram you can draw whenever the question come in your examination. You have to draw such kind of simple two-dimensional diagram. So this is the bore diameter. Now this is V suffix C. See, these are the letters which are very much useful to describe the clearance volume. V suffix C, which represent for clearance volume. Then this is the swept or displacement volume. It is always represented with the help of V suffix S, that is piston traveling in between TDC to BDC, or the volume swept by the piston. So this is the stroke or the stroke length. As I told you earlier, stroke length means what? Piston moving from one dead center to another dead center. If it is traveling one time, this is the single stroke. Again, if it is moving from another dead center to other dead center, the second stroke, like this. Okay, so this is represented with the help of letter L. Similarly, in this case, V suffix T is nothing but total volume of the cylinder. This VT. Okay. Now from the BDC point to this topmost portion of the cylinder head, this total volume is nothing but called as a V suffix T. Okay. If you see in this diagram, we can say VT, that is total volume of cylinder, is nothing but swept volume plus clearance volume. This is very simple. Vs plus Vc is nothing but gives us a total volume of cylinder, that is Vt. Okay. So if you want to read the definitions, the theoretical definitions are present over here. Bore, that is the nominal inner diameter of the engine, and it is expressed in mm and designated by the letter D, as we discussed with the help of the PPT itself. Now the piston area means the area of the piston, that is area of the circle of diameter equal to the cylinder bore. Okay, is called the piston area, and it is designated by capital A letter and expressed in centimeter square, because this is the area. Similarly, stroke length, it is expressed with the help of letter L and in mm, as we discussed. So stroke to bore ratio, this is the another one. Stroke to bore ratio is nothing but called as the L by D ratio. Okay, always stroke to bore ratio is very important to define the size of the engine. With the help of this L by D ratio, we come to know if the engine is a large one or square one or over square one. See, the things are given. If this small d means nothing but the bore diameter is less than the stroke length, then the engine is nothing but under square engine. If d is equal to L, this engine is nothing but equal to the square engine. If the bore diameter is greater than the stroke length of the engine, that time the engine size is over square engine. Okay, these are the things about the stroke to bore ratio. So similarly, dead center, we just discussed TDC and BDC. We had definition also. So displacement or swept volume, this is about V suffix S, which we discussed. So it is always expressed in centimeter cube, and If we want to write in mathematical way, then we can write the swept volume. See, general definition of volume is what? Volume is nothing but area into length. So A into L, here we can write area. This is a cylindrical portion. So the area of cylinder is always pi by 4 d square. Small d is diameter of that cylinder. So pi by 4 d square into the capital L, that is the stroke length. And this is the volume. That's why the unit is centimeter cube itself. So this is about the displacement volume. It is always shows with the help of unit centimeter cube or cubic centimeter, cc or centimeter cube. So the next one, cubic capacity or engine capacity. So always, I think every one of you heard about the cc of the engine. When you are going to purchase or when you are going to buy a new bike, okay, what you are going to see? What is the cc of the engine? 120cc, 150cc, 200cc. If you consider the Bullet, 350cc engine is there. Now if you consider for four-wheeler, then 1.5 liter engine means 1500cc, 2.1 liter engine means 2100cc engine. Okay, what is cc? cc is always the indication, the kind of power developed by the engine. So by definition, the cc is what? The cubic capacity or engine capacity is defined the displacement volume of a cylinder multiplied by a number of cylinders in an engine, which will give the cubic capacity or the engine capacity. Okay, we just discussed this particular displacement volume means what? Actual volume swept by the piston when it is traveling from TDC to BDC or BDC to TDC, and CC means what? Suppose here is only single cylinder. Okay, if it is single cylinder, and when we are going to consider the multi-cylinder engine, 1, 2, 3, 4. If the multi-cylinder engines are then how we can calculate the CC? Generally, we can calculate the CC in that time V suffix S into that number of a cylinder. This is designated by letter K. This gives us a complete CC of the engine. So according to the definition, the displacement volume of a cylinder multiplied by number of cylinder in an engine will give the cubic capacity or the engine capacity. So always remember, dear friend, if the cc is high, definitely it produces the huge amount of power, and cc is the indication of the power of the engine. cc is nothing but engine capacity or the cubic capacity. This is one way to define the power of the engine. Okay, so again the clearance volume, as we already discussed, expressed in again volume is there, so centimeter cube. And the last thing which remaining to understand, the compression ratio. This is very important. Okay, by the definition, what is the compression ratio? It is the ratio of total cylinder volume when the piston is at BDC to the clearance volume. Now again we are going to see the diagram. It is the ratio of what? Yes, it is the ratio of this swept volume and the clearance volume. Okay, total volume of cylinder is what in this case? Vt. So once again, please read carefully this definition. It is the ratio of total cylinder volume. What is total cylinder volume? V suffix T. Here I am written over here in this derivation part or equation part. V suffix T is total volume of a cylinder when the piston is at BDC to the clearance volume. Now what is the clearance volume? Vc. Now again look at the diagram. The total volume is Vt and clearance volume is Vc. Now can I write instead of Vt Vc plus Vs? Yes, of course we can write. So whenever we are going to write the equation for compression ratio, we can write compression ratio is designated by letter small r, and it is equal to the total volume of cylinder divided by clearance volume, which is equal to Vt means Vc plus Vs. Vc is clearance volume plus Vs is swept volume divided by Vc. Now this Vc and Vc will get cancelled, and what is remaining? 1 plus Vs by Vc. So these 9 terms are come under the complete engine nomenclature or the terminology. Okay, so this is a very important point. Unless and until understanding of these things, we can't move further, because whole engine subject, IC engine subject, is depend on this particular terminology. So I hope you understood well these particular points which I covered today. So again, in the notes, as we discussed the list of engine parts and material used in the last lecture, all the things are present over here. Okay, so thank you.